Hi, questions in mechanics. In this textbook, problem 8.15 shows that the Kepler's third law should read as this one, and hence that the constant of proportionality is actually a little different for different planets. Given the masses of Jupiter and the Sun, by what percent would you expect the constant in Kepler's third law to vary among the planets? Solution. We have this result. We have this ratio. Then we find the result of this example. Problem 8.16. For this case, rewrite the equation of Kepler orbit given by this form in rectangular coordinates x, y, and prove that the equation can be cast in the equation of an ellipse. Solution. Consider this case. We see this equation. This gives this equation. Then we get this result. Problem 8.19. The height of a satellite at perigee is 300 kilometers above the Earth's surface, and it is 3,000 kilometers at apogee. Find the orbiter's eccentricity. If we take the orbiter to define the xy plane and the major axis in the x direction with the Earth at the origin, what is the satellite's height when it crosses the y-axis? Solution. We have this equation. This gives this result. Then we get this result. Problem 8.20. Consider a comet which passes through its aphelion at a distance r max from the Sun. Imagine that, keeping r max fixed, we somehow make the angular momentum L smaller and smaller. Show that in this limit, the eccentricity epsilon of the elliptical orbit approaches 1, and the distance of closest approach, r min, approaches 0. Describe the orbit with r max fixed but L very small. What is the semi-major axis A? Solution. We have this equation. Then we see this limit. And this limit. Then we have this conclusion. Then we see this result. Thanks for watching. Bye.